Right, we're live, people. Welcome everyone watching to tonight's session about heat pumps. We're joined by some new faces to the group tonight. They might not be new faces to you all, but they're new to our Facebook Live sessions. I'll let them introduce themselves in a minute. Tonight we're going to talk about heat pumps, and while we've seen some reticence in the industry about the heat pump revolution, hopefully tonight will be a bit of a help to explain a bit more about why the government are focusing so heavily on them for the net zero journey, and how you guys can get on the bandwagon in terms of upskilling if that's what you want to do. So first let's do a bit of a round table and start with Rhiannon. Tell us a bit about you.
Hi everyone, my name's Rhiannon de Wreede. I work for a company called 𝗺𝗲𝗺𝗺𝗃. Despite the name, we also fit heat pumps. So I do all the systems design, I do the surveys, liaise with all the engineers, and every now and again I'm on the tools.
Great, thanks Rhiannon. Simon?
Hi everyone, I'm 𝗫𝗿𝗁𝗆𝗃. I currently work for Seabrooks Plumbing and Heating. We're predominantly heat pump installers in and around the southwest Bristol area. Fitted my first heat pump in 2008, and kind of on and off I've been heat pumping ever since, and focusing the last 2 or 3 years solely on heat pumps.
Is that what we call it, heat pumping? I love that.
That's what I call it, yeah.
Love it.
Nice.
Graeme?
Hello, my name is Graeme Heron. I work for a company called 𝗵𝗲𝗁𝗃𝗃, who are a specialist consultancy. So I work in the low carbon business unit, and we do a lot of sort of consultancy and policy work for clients, and particularly my job is to deal with heat pumps. And I've been here about 5 or 6 months now, but my background, I'm a heating engineer by trade, and it's like I say, it's worth looking at my LinkedIn profile where I haven't worked. So I've been involved in, renewables and heat pumps in a number of guises. Worked in colleges, teaching, worked on the tools, manufacturers, energy companies, and work for a certification scheme as well.
Thank you, Graeme. Richard?
I'm Richard. I'm Director of Mid-Wales Plumbing and Heating Supplies. Have a heat pump. So we sell heat pumps. We do heat pumpy things, amongst most other stuff. Yeah, that's about me.
Fantastic. And Ken?
I've been doing plumbing and heating for 30 years. Worked Daikin for 4.5 years as a heat pump specialist there. Been doing heat pumps for 15 years. I've one myself. Have 𝗵𝗲𝗁𝗃𝗃, thermal, and yeah, generally an eco guy. I don't like gas anymore. Want to be doing pumping everything that is possible if I can.
Fabulous. You are a little bit glitchy there, Ken, but we'll work through it. And everyone, I'm sure, understands the wonders of modern technology. So to start with, I'm gonna ask Graeme to explain the why bit and why heat pumps are the big focus of the government. We've heard these massive numbers of 600,000 to be installed by 2028, which obviously is quite ambitious. Can you just tell us a bit about why this target has been set and what the heat pump thing's all about?
Yeah, without doubt. So it's quite a few stats in relate to this. So I'm going to try not to cover any more figures after the first few minutes. But the 600,000 target is by 2028 as part of the government's 10-point plan for the green industrial revolution. And the UK government have actually made a commitment to hit net zero by 2050. And they have got an ambitious target to cut emissions by 78% by 2035. So that's quite a considerable amount in 13 years away. So if you look in 13 years' time and where you were 13 years ago, 2009 was only 5 minutes away, so it's not far off. But currently in homes, about 70% of UK homes, 70% of UK greenhouse gas emissions come from heating in people's homes. And currently about 85% of homes are heated by gas boilers, and at the moment there's about 1.7 million gas boilers sold each year. Okay, so compare that to heat pumps in the UK at the moment. So it's only about 2% of the heating share is heat pumps, whereas we go to the opposite end of the scale in our European neighbours, so like Norway, for example, who are way ahead of the UK. About 97% of their heating in people's homes is a heat pump, so they're way ahead of us. But heat pumps, you know, they offer huge carbon savings, and now around about 65% versus a gas boiler. So that's sort of the baseline of why we're going and why we're trying to reduce carbon emissions. But there's some sort of key drivers that the government's sort of, you know, forcing onward as an industry. You know, the future home standard, so that's going to be introduced in 2025. So, and the heat pumps will be the dominant technology in that, and that coincides with the perspective sort of gas boiler ban in new builds by 2025. So in a new build property, you can't fit a gas boiler. It's got to be a renewable energy source, which is likely going to be a heat pump. We're also looking at again, it's not set in stone, but there's a 2035 retrofit ban. So from 2035 in England, you can't replace your gas boiler with another gas boiler. It's got to be a renewable source, which again likely to be a heat pump. They are talking about sort of, you know, possibly phasing out of off-gas retrofit by 2026. You know, that's still being considered. So if you've got an oil boiler at the moment or an LPG, by 2026 retrofit, you would have to go down again a heat pump route. In Scotland's quite an interesting one, so I'll jump to Scotland. They're looking at 2024 new build ban and a 2030 retrofit sort of ban on gas boilers. But we've just done actually a bit of a consultation for the Scottish Government on new build. So we've responded to that for a number of our clients. And if the Scottish Government actually brought that date forward from April 2024 new builds to October 2023, that's potentially 10,000 less fossil fuel burning appliances that will be installed in Scotland. So that's quite a mountain. Obviously, Scotland's a lot smaller than England. So you can see, you know, if we did bring these, you know, bans forward, you could see the massive savings for the, you know, for the carbon emissions. And so the last 2 points, so, you know, the new Part L, you know, recommends low floor temperatures, you know, 55 degrees and below, which is, you know, aligns with the Scottish and the Welsh government policy as well. And finally, I've worked in, you know, ECO, which is energy company obligation, and part of my job in compliance of that was dealing with a lot of boiler installations. But in ECO 4, you're only allowed to fit around 2,000 boilers across all energy companies. And in ECO 3, the previous 4 years, you're looking at over 100,000. So you can see there's quite a bit of drive towards renewable technology and phasing out fossil fuel appliances.
Brilliant. That's really good stuff, Graeme. Thank you. So Rhiannon, Richard, I want to kind of understand what real world scenarios. So obviously, you know, they're not suitable for all buildings. What's the most, outside of new build, what's the sort of best type of house or most suitable type of house, or are they suitable for all houses or not, or, you know, that sort of real world scenario? What does that look like?
My sense is we can fit them in any house. Heat loss is heat loss. If you've got a leaky old house, it's going to cost you a lot with a fossil fuel. It's going to be, you know, using a lot of energy to keep you comfortable with fossil fuel as it would with electric or with a heat pump. Heat loss is just heat loss. I've you know, put them in 400-year-old places and well, obviously new build. But interesting point you said there, Graeme. I had a meeting today actually of a new build we're doing in Bristol, and we had a big team together. We all got together. There was timber framers, steel design guys, SAP guy, and the SAP guy was telling me he cannot pass with the new Part L. He really struggles to pass the SAP with the new SAP with anything other than the heat pump. And that's there right now. That's live since June. He's struggling to justify anything other than the heat pump in a house with the new SAP rules.
Yeah, that's a great point, because I know builders and developers in the past would have a bit of a token gesture to try and get carbon emissions down. You know, I've seen properties developments in the last 10 years where they put 2 or 3 solar PV, but obviously now, you know, the improvement in SAP is fantastic. So yeah, so that's another, you know, key driver as well. So
about 5 years too late, but yeah, you know,
yeah.
Good.
Yeah, I mean, some of those stats really make you think about Europe as well and what they've done over there. It feels like we're so behind, especially with all our electricity supplies. The amount of times people come to us and like, I want this, I want this, I want this, and they're on single phase.
Yeah.
It's a real sort of holding things back to electrify everything, I think, the infrastructure that we've got in place.
Yeah, I think the compliance point's really important, though. I think from that perspective, you need the compliance guys coming in and enforcing it and making sure, a new build. Obviously, you got the SAP and everything that sort of takes care of that. But on the retrofit stuff, boilers are bad as it is, as we well know. But who checks the checkers in a lot of these situations where the MCS standard is failing or has failed one way or the other. I don't know what it is, but it's failed. So it's so many heat pumps go out there that are not sized correctly, or they're the pipe work's incorrect, or the heat emitters are not small, not big enough to take a lower flow temperature. So there's just so much going on. But I don't know. Si comes across it more than I know. It's a shame Ken's not there, because I know Ken's like scrapped his gas and everything now. He's he's heat pump only, just because that's the way of the future as far as things go.
Yeah.
We're talking about boilers last week, weren't we? But ultimately, heat pump is definitely the way to go, especially from energy infrastructure point of view. And what we're going to do, direct heat everything. It never works that way, does it? No.
And a heat pump's the only energy multiplier I know.
Yeah.
Other than the sun, But.
Yeah. You know what? There's an interesting one the other day, Si, right? Someone there was a guy, and he was on one of the group. I think it was on 𝗵𝗲𝗺𝗁𝗺 group. I'm not going to name his name, but he was like, "Oh, heat pumps this, heat pumps that, no good. Stick with the gas boiler." He said, "Oh, what?" One of his things he put up was, "Well, what's going to happen to all the energy when it gets sucked out of the atmosphere?" Yeah.
Yeah. It's a total lack of understanding, but that's not a new thing, and that doesn't seem to be like. I feel like it's not going anywhere. You hear that sort of stuff all the time, and also the balance.
Honestly, the person who said it as well should have known better. But he said, "Oh, all the atmosphere is going to go colder because we're sucking all this energy out of the atmosphere." And I was thinking,
it might be a way of combating global warming, though, Rich.
It's just the problem. Yeah, just the problem of it re-leaking out of those leaky houses, isn't it? You know what I mean? It's I was like, we got so far to go on this education piece. It's unbelievable.
Absolutely, but, we see a lot of these comments when we post the ad for this session tonight. We see people commenting and saying heat pumps are crap, and what are you talking about, the heat pump revolution? And it's like you say, it's just an education thing, and that's what we're trying to help with here.
But it's so frustrating. Sorry, it's just such an established technology. It's been around for a long time. It's one of the things Nathan always talks about. This is not new.
And I think the education piece is key. I've worked in colleges and training, and you can teach heating engineers it no problem. But what's really pleased about the last year, and it's a shame it's took an energy crisis to sort of get the general public understanding it. And I think getting people to understand low flow temperatures is a big thing. You're still going to be warm. It's just a bigger radiator, or in most cases you might not need to replace your radiators. There's a big push now to turn your flow temperatures down, or use controls that can modulate down for your boiler, so your property's heat pump ready. And it's great at the moment, because I get quite passionate, excited by heat pumps. My friends think I'm a bit mental, but it does when you work in this industry. And like I say, I've never known so much sort of press about it, so much media, and it's a really good time. But there is a big education piece, and I think that's good for customers and installers. But I see, and I think in the heating industry especially, installers are keen to go on training courses, keen to learn. We talk about low temperature design. There's courses available now where installers can go on. There's lots of that being done. So yeah, it is a great time, but it is a long way to go to sort of try and get them 600,000 a year by 2028. Definitely.
Yeah,
a massive hill to climb. Massive hill that is. We're still only what we're doing. We're about 30,000 a year, Graeme.
Well, yeah, I think it's a bit more. I think we're looking about, well, RHI sort of jumped quite a few because there was a big push, and I was working for a certification body come March. So you're probably looking about 50,000-60,000 probably for about 2022. So we're still way behind, and we can touch on the grants in a bit about the boiler upgrade scheme, and obviously that's been a bit of a slow starter, but it's getting there. But that's only 90,000 a year over 3 years. So we still need probably about 3,000 a month the rest of the term for the boiler upgrade scheme till March 2025. So it's still pushing. But I think lots of grants and funding out there, but I think there's a bit of a carrot and stick approach, isn't it? We've had the carrot for a long time. The RHI was fantastic, but now obviously the stick's sort of like cost of energy. on certain scenarios, gas can be cheaper than heat pumps are cheaper to run than a gas boiler. There's a lot more gas boilers being replaced with heat pumps,
providing the performance is right.
Yeah, exactly. You've hit the nail on the head. The performance is key and critical, and this is where the the education piece of the customer. But bigger systems like ground source heat pumps need a lot more funding. So part of my job is to push government to try and improve that funding as well. But so fingers crossed the funding continues. But it is the education piece is the customer, and yourselves as installers, it's educating the customer. You'll get a lot of, and I've listened to Nathan's podcast as well about the time you spent interacting with the customer before they've actually signed with the contract. So there's a lot of work involved in that as well. So,
yeah, definitely.
Absolutely. Yeah.
I found it interesting what you were saying about Scotland and the things that they're doing, because I know that they're doing interest-free loans, aren't they? Or they have done for quite a few years for a renewable technology. An interest-free loan seems like such a no-brainer. And we're worrying about grants and all the paperwork and admin that's involved in that.
Yeah, well, that's been around a long time. I've actually got some notes on that, Rhiannon. So hey, well prepared. But it's what's called the Home Energy Scotland loan. So it's homeowners can access the following: so up to £15,000 to improve home energy efficiency. Up to £17,500 for installing renewable energy systems, such as £10,000 for a heat pump. Also open to self-builders, which is the same as the bus as well. Up to £6,000 for energy storage systems, up to £500 for installing a heat meter. So it's quite a bit more fun than England, and it's there, and it's been there a long time. And also, again, going up piece slightly. Sorry, Claire, there was a set agenda.
No, don't carry on.
But Scotland also has something called sort of like an MCS sort of a certification fund. So new installers can actually join the MCS scheme with funding towards it. So it's got to be for new MCS companies, but again, it's been there. Well, that only runs till April next year, but again, there's an opportunity for Scotland and funding. Whereas it's sort of in England, there's very few sort of funding opportunities to upskill. We've got a massive sort of upskilling program to go ahead, and I understand people taking time off the tools to do work. If you're doing a low temperature design course, if you're doing a heat pump course, and you might have to do unvented qualifications, water regs, you could be off the tools for 2 weeks. But I think there's some room for support for government to support engineers on that. I appreciate once every 5 years we'll go and do access assessment, apart from Ken, who doesn't need to do that anymore. But yeah, so there's certainly something that can be looked into that. But there is certain funding available. So if installers are looking for heat pump training funding in the area, it's worth Googling. Particular areas have got them, some they've got 50% funding. But there's something called the Home Skills Decarbonisation, Green Skills Decarbonisation Fund, which is being tendered for now. So the government's looking at trying to get 3,000 new heat pump engineers trained up or upskilled by April next year. So that tender actually hasn't been awarded yet, but sort of interesting that it's got to be complete by April next year, when a lot of heating engineers be busy in the winter months. So again, some of the feedback, but there's stuff there. But yeah, so and I think that's all my notes done. I may as well go now. It's like you pack lunch on the school bus.
One thing I just want to question about, Graeme, is the training aspect, because we know an installer, myself and Si, who's been on the low, was it the low temperature course or whatever it was, Si? I think it was.
I didn't personally do it, but a friend of mine did. Yeah,
and it wasn't very good, and it was to the point at which the guy who did the course knew more than the guy lecturing on the course. So there's a couple of holes in the thing, and I was just wondering, the way the government are awarding it out to the training centres that they are, how are they kind of vetting that to make sure that it is at a certain level that the guys that are going through it?
Yeah, well, I've got a bit of a sort of mandatory technical competency review at the moment, so there's going to be some consultation on all qualifications. So there's only really one on the low temperature design course. There's only one off-qual approved qualification, which is the LCL Awards, which was sort of developed along with 𝗵𝗲𝗄𝗎 and the Heat Pump Association. Again, so it's any funding that's sort of offered, you would really thought it would go to an off-qual approved course. So it's government recognised qualification. I know there's other courses out there, and there's other courses that may jump on the off-qual bus, pardon the pun, in the future, which is great. But that's likely going to be the route that any future funding will go down, and it's also likely going to be the route when the MCS confirm their competency criteria. I know they've just updated it recently, but it will be in line with the MTC. So we've got sort of minimum technical competencies, and I suppose it depends on your certification body. You know, I used to work for the NICIC, and we used to insist any new technical reps had a heat pump qualification, recognised one, so whether it's 𝗵𝗲𝗁𝗃, LCL Awards, or City and Guilds, or whoever. I probably missed one out there, and I'm probably going to get shot. But yeah, and again, that's going to be sort of set in stone now, which is what we want, because installers, you know, especially heating engineers, I'm one of those square peg in a square hole, and if I'm going to go on a course, I want to know it's the one that's approved. It's going to get me funded, and that's going to take time. But you know, in about 18 months' time, when the mandatory technical competencies probably come into play again, this is all up in the air a little bit at the moment because we need to consult on the first. There will be recognised qualifications. But the point you made, Rich, about design, it is, you know, I've done a couple of design courses and I've been like, whoa, you know, this is a bit heavy stuff for if someone who's on all the tools all the time. But I think naturally the industry is going to evolve. And I think what we want is just a simple app. You know, I'm never off my phone. My kids are never off the phone. We just want things made simple. And you have an app, put a few figures in, it comes out with exactly what you need. But experienced heating engineers probably can tend to use a bit of their own knowledge and an app to confirm the heating system's correctly sized, rather than go through, you know, a 𝗵𝗲𝗁𝗃𝗃 type countdown, you know, equation to work out what the heat loss is. But
I think you need. I think you do need a fundamental knowledge. You do need the fundamental knowledge to know when you're using the apps, and I use apps all the time to do my designs, but I think you need that fundamental maths knowledge to kind of know how that app's working in the background, really. And I think that's key, because I got invited to, I won't name the manufacturer, but a kind of future of heating day down in Bristol the other week. The great and the good of Bristol gas guys were there. Everybody, you know, I knew loads of guys there. A friend of mine stood up and talked about heat pumps, and the other guy stood up and kind of his boss and talked about hydrogen. And the hydrogen guy was bombarded with questions. You know, NOx, price per kilowatt hour, leakage, blowing the roof off the place, all that, you know, all the stuff that everybody's worried about with hydrogen. The heat pump guy stood up and talked about mean water temperature and DT50 and DT30 and how we size for low temperature, all the stuff that works for low temperature. And he got asked one question, because he lost the whole room as soon as he started talking about DT50, DT30, DT25. He didn't have a clue what he was talking about, and that's the key thing. It's understanding low temperature design is low temperature. It doesn't matter what the heat source is. It's all the same. All the same.
Yeah, and I think that's what reflects in Part L. You know, now with, you know, you're making people's properties heat pump ready, aren't you? With new systems and stuff like that. But I do understand. You know, I've done my college training a long time ago, and you know, you do forget, because gas boiler manufacturers have made it so easy for you. You know, I've been guilty of. I stuck a combi boiler in my cousin's 3-story Victorian terrace about 16 years ago. But there's only her and her husband really now. The kids have moved out. Still works. It's fine. You know, it's probably still oversized for the property, and then the same boiler can go in a 1-bedroom apartment. But I think the key is the education, and it's making simple for engineers, because we've all been used to just turning up, putting a box on a wall and walking away, and the manufacturers have helped make it easy. But granted, heat pump manufacturers, you know, I've got to stick up for them. I deal with a lot of them. They do spend a lot of time on training, a lot of time with helping engineers, and they're putting a lot of money involved in upskilling. But again, it's got to be done the right way. And I think it is early days. You know, we're sort of, you know, teaching people something that they were taught a long time ago. But again, it's keep it simple, as I say, you know, simple as possible. You know, give them some baseline knowledge, and that's part of the mandatory technical competency review, where people have got to have some sort of background qualification, plumbing and heating, and then gradually phase in them, but give them the technology to help them, you know, and helps the customer as well, and gives a bit of confidence to them.
I think we've just had a comment which I think is quite appropriate for this point, but Paul Spence has commented that the hydrogen is perceived as easier for the unqualified installer to fit and deal with, because it's just the same sort of system as we're working on at the moment, isn't it? So
gas, yeah.
Yeah, so it's gas, and it's perceived that, and I understand that, hydrogen is part of the solution, but I think that it's the common in the industry. People are thinking, well, it should all be hydrogen because, it's the same system. Nothing needs to change. We don't need to do anything differently. Okay, different boilers and whatever, but, it's only part of the solution, and heat pumps clearly are the bigger part, aren't they?
Hydrogen's about 6 times more intensive than it is to run a heat pump. So you could take one part of energy and produce hydrogen, which could potentially run one house. You take that same energy and you put it into heat pumps, you could effectively run 6 houses with that same energy. That's Absolutely. How bad producing hydrogen is.
Yeah.
And how much is it per kilowatt hour, Ken? No one's saying how much it is per kilowatt hour.
No one knows. No one knows.
No, and domestically we don't really measure NOx.
Yes, but producing the blend
4 times the amount.
Yeah, the blend is definitely more NOx producing than just burning gas. So in actual fact, it is actually cheaper and more efficient just to burn gas, not a blend.
Yeah.
And there's plenty of studies and people that are much more clever than I that can actually crunch the numbers and just said it's not possible. I'm not saying it shouldn't be done. I'm just saying as a mainstream heating appliance, I don't think hydrogen is what we should all be looking at.
Certainly not within the time frame that we're looking at.
No,
we haven't got long.
No, we can wait 20 years and hydrogen might be lit, but I don't think we can wait 20 years.
But we're still going to be designing heating systems at low temperature anyway, whether it's hydrogen or heat pumps.
Yeah, I mean, going to that point, Graeme, I even said that. I mean, Simon and I and Richard know each other from a long time. Some of us were doing low temperature systems 20 years ago. I've got a book from a radiator manufacturer that actually came out in 2010, 2011, which was promoting low temperature systems back then. Even at the installer show, I did say that, why are the boiler manufacturers selling boxes that have built-in weather comp, set up at 50 degrees flow in 55 degrees flow in heating, and cannot go any further? And you would then create a low temperature industry overnight, and those existing gas engineers would then be forced to have to do proper calculations, to do proper rad sizing, and not just put a finger in the air and get away with it, which is what unfortunately a lot of the industry is. Many a times we've taken out gas boilers that are 42 kilowatts and then we're replacing them with heat pumps that only need 12 kilowatts. So the property only needs 12 kilowatts of heating. So
sorry, I was just going to say, when does the accountancy come in for all of this? Because ultimately we've had periods of time in the past where we've been fitting gas boilers, and British Gas have been going out fitting bigger boilers because they're the ones that they've had excess of, or and things like that. We've had really underhand sales techniques in the past. When there's a lot of people, because I noticed on the question someone said about the level of detail and the liability that comes with heat pumps, but what about the liability of gas boilers? Because ultimately, there's oversized systems been put in for the last 20 years or more, and where's the accountancy for all that? Who's liable for all that? Actually, whose mistakes are they? Obviously we're trying not to make these mistakes going forwards into heat pumps. That's why the education piece comes around about the low temperature space heating, the design around that, everything else. But ultimately, that should have all come out in 2005, the second we went to condensing gas boilers anyway. So, like someone just said, there's no liability with oversizing a gas boiler, but there's liability in place for oversizing a heat pump or undersizing a heat pump. And do you know what I mean?
I think that's a great point, because sorry to bore you with more consultations, but there's a current consultation for the Competition Markets Authority on consumer codes, and it seems to be, and somebody mentioned there about MCS as well, it seems to be the funded industries always have to have, you've got to be part of the consumer code, you've got to do extra consumer protection, whereas a standard fit in the boiler for a private household, that just, all they've got to do is gas safe registered, and that's it, and provide a warranty. There's no other additional consumer protection. And so if that was rolled out across the whole heating industry overnight, you would yes, the costs for gas boilers would probably creep up, because there'd be an extra burden on that. But then it would then assist with pushing towards heat pumps as well. It's a bit more of a carrot and stick, so that's the stick to move people over. So so that's an interesting point that we're responding on behalf of clients that you've got to be MCS approved, you've got to be this, you've got to be that, go through all the training. Whereas anyone can just anyone who's gas safe qualified can just fit a boiler, get gas safe. That's it, done, signed off, see you later. Whereas, we're jumping through hoops as an industry for funding, which is, okay, £5,000 for an air source is reasonable, but £6,000 for a ground source is way below what it should be.
Nothing, yeah.
Nothing at all.
Yeah.
So,
Claire's got to jump in.
I've got to jump in now. Engrossed. So, okay, so that's kind of like hydrogen covered really, really briefly, and where we're at with the heat pump installations. So let's talk about why you guys made the decision to switch to be heat pump installers, because obviously we've got loads of guys out there who are gas safe engineers, and some are thinking about it, some are not thinking about it, which is understandable. Some of them maybe of an age where they might not need to ever do heat pump installations, and they're quite happy doing what they're doing, which is great. But obviously the younger generation are coming on through, and we need to be able to help them and encourage them to want to invest in this technology. And what did you guys, what made you go down that road, and what was your experience to sort of push you in that direction?
Well, I've probably been in the industry the least amount of time. So if I start, basically, I retrained as a plumber, and then the option is gas or heat pumps. And in my previous life, I was a scientist. Everything's quite cutting edge. The whole point of science is you're doing new things and stuff that isn't necessarily established. You're finding out things. And for me, gas just seemed like a step backwards, to be honest. So then I went down the heat pump route. Nobody in my college could teach heat pumps. I mean, my lecturer didn't know what 𝗫𝗺𝗺 was. He had to pause lecture and come back after a break. So, and then I got obsessed with heat pumps, and fortunately found a company who have taken me on and trained me up. But I like the cutting edge side of it. I like it's new. It's got a real buzz about it. And I think anyone who does come into the industry and wants to learn about heat pumps will get involved in that buzz, and you're helping save the planet. So it's kind of a no-brainer, really.
For me, I think I kind of similar to you, Rhiannon. I kind of changed career in about 2000 and came from engineering, cutting edge R&D, engine development, that kind of stuff. Moved over to plumbing, drifted into gas, did the normal stuff. Worked on a family friend's farmhouse. We were having a ground source heat pump put in 2007, and kind of went from there and ended up working for the company that put the ground source heat pump in. And anybody that's old enough to remember that it was going to be gas free in 2016. Tories got in and binned that. Now we're looking at 2025. So I kind of drifted into heat pumps about 2008 and cut my teeth doing some terrible installs, if I'm honest. Didn't understand about flow, DT. We were poorly advised by the likes of Roger Bisbee and 𝗵𝗲𝗁𝗆, and Roger was the face of 𝗵𝗲𝗁𝗆𝗆's green revolution back then. And kind of went on my own path, met Adam and other like-minded people, Adam from Heat Geek, and in about 2015, and kind of did my own learning about what the hell's DT, what's that about, how does that affect flow and the delivery of kilowatts and all that kind of stuff, and just got a bit nerdy about it, really, and unfortunately that's what's needed. You need to kind of understand the maths and what effect stuff has on different things, and that's how I got into it, and I love it.
I like the fact you said about the 𝗵𝗲𝗺𝗃 thing, because I was exactly the same thing. 2008, I did a 𝗵𝗲𝗺𝗃 course because I was still on the tools at that point. Yeah. And nothing about flow. We got the video of Roger Bisbee on the projector. Do you remember that and stuff?
I do, mate. I do. Outside, it was the MD's house, wasn't it?
No, we went up to it. No, we actually went up to it. Richard 𝗃𝗍𝗍's house.
That's it. Yeah.
And they'd not long
put it in cold Richard 𝗍𝗍.
That's it. The irony was, when we went there, they had an open chamber where they showed you the ground loops in the ground, right? And it was frozen solid, right? It was absolutely frozen solid as you looked down. Yeah. And like you said, there was nothing Nothing about DT, nothing about flow, nothing about the importance of,
I mean, if you remember that old IVT heat pump, it had 22 mil tappings on the top, so everybody went, "Ray, let's put 22 mil pipe on it."
I just go quickly, jump in. I remember that video well, because when I used to teach at colleges, that was the go-to video, and I remember Roger specifically saying, "Now this is a badly insulated house." And I know we're talking about heat pumps can be used in every applications, but that was early days. I just thought, okay, we've got a long way to go.
and it was all in 22 mil pipe.
Yeah. Well, yeah, because it was 22 mil off the top of the heat pump. Right. So everybody just assumed that was fine. And I see that every day now. Even now, it's like, well, it's an inch tapping off the back of the heat pump. Well, yeah, but it's about how much flow you need. Yeah. You might have to take that to 42 mil as soon as you come off the back of the heat pump.
So you're right. You've got to get nerdy about it. Sorry, Ken.
Yeah, you have. I came into it from trying to do the most efficient gas boiler systems I could, and because you then start digging into holes and having a look, I came across this technology called a heat pump, and it's all about low temperature. And as I said, I was actually trying to do low temperature gas systems back then, weather compensated, open loop, ditch all the controls. I may have broken some of the building Part L laws back then, but in my opinion, and doing the math, I thought my systems were running much better than putting zone valves everywhere.
Absolutely.
So then, I came across this technology called a heat pump, and then I started digging, and then it was like, well, this thing, you put one part of energy in and you get 300 or 3 parts of energy out. It's like 300% efficient. And then eventually I got my head around it, and it was like, well, there's no other technology out there that does this, and it gives you heat and hot water. It's electric, and so you start looking into the PV, and there was the PV boom, and as Simon said, gas boilers were meant to be banned in 2015, and it never happened, and got lobbied by the house building industry, and don't get me going on that one. But it's, and then I started looking at it from an eco-environmental point of view. You delve, and you do become a geek and a nerd. You delve into it so much. Your average gas boiler produces, 45. It's either 4.5 tons of CO2 or 45 tons of CO2 per year. I can't remember off the top of my head. That's pretty much every gas boiler in the country that's doing that. You start looking at
about 25% of that, aren't you? With a heat pump.
You start looking at the technologies from different angles, from an environmental angle, from a comfort. Running the system for longer but lower temperatures. That's more comfortable for the fabric of the building, more comfortable for the fabric of yourself. Making it simple. It got me nerdy, and I was just like, this is going to be the future. Gas is fine. I already knew gas was going to be I researched into it, and gas and oil was going to be is a finite resource. There is always was going to be a change. Unfortunately, I think we could have done the transition better and not. But we're now firefighting, and the cynic in me would say we're only firefighting now because there is actually a climate change, and we're being forced into a corner. You know, we could have been insulating houses better. We could have stopped doing gas boilers in new houses. We could have narrowed the gap down so tight that the transition from doing a gas boiler to a heat pump could be made easy and simple. But we've still got this massive gap of, yeah, Mrs. Smith, your house has been having a heating system that's been fitted based on technology and thinking that's like 30 or 40 years behind the times. And now we've got to, the reason why it's so expensive, Mr. and Mrs. Smith, is we actually need to bring your system up to a standard, a low temperature standard. And then we put the heat pump on the end. And that's half the problem that we face now.
Agreed.
Yeah, I agree. Yeah, but I sort of how I fell into this industry. I went sort of back to the front. I was mentioning the chaps before came on the call. I was offered a job at a college, and they says, right, we're shutting the plumbing department after 3 months, but we're going to set up a renewable energy academy. Do you want the job to run it? I thought, oh well, I better. And went through all the 𝗵𝗲𝗁 courses and all that and set it all up. And it was quite a successful training academy, to be fair. But but when you're just reading off slides, you know, and just not fully understanding the technology, and again, back and then there was no mention of real low temperature system design. It was just they work better at low temperatures. But to be fair, was quite engaged, you know, and it was again Northeast England, Sunderland College. It was brilliant. We had all the kit with 𝗵𝗲𝗁𝗍𝗃 and Burrows, various manufacturers. Had the 𝗵𝗲𝗁𝗍𝗃, you know, the 𝗵𝗲𝗁𝗍 ground source unit on the trolley. You might have seen that. And underfloor heat manufacturers support with Mason, 𝗵𝗲𝗁𝗍𝗃, unvented cylinders. We had all them put in, and we had a gas assessment centre that had been gathering dust for years, so that was open and that become a commercial, sort of commercial part of the building as well. So we'll get running gas assessments as well. We'll make quite a bit of money in the sort of the 18 months I was there running it. But I always remember the first air source we got was a triangle one. I think it was another Roger Bisbee video. Have you seen the triangle?
Yeah.
And he puts one on the side of a building, and then he puts one in a loft. Fantastic.
Okay.
And I used to be as a college lecturer, and I was like, people would look at me, and I was just basically knew slightly more than the people that were in the room. They said, who's this Graeme? He's the font of all knowledge of heat pumps, and I'm showing them these videos. And now they must thinking that bloody Graeme Heron, what was he teaching me back in 2010? But yeah, so I've so went the opposite way. Then had to go and work for an installation company to sort of fully understand the nitty gritty. So yeah, so I had a bit of a topsy-turvy, but now the training really needs to be pushed on. So we'll interested to see what support we'll get from the government moving forward.
Well, it was
the
just
training needs to be done better.
Yeah. Sorry.
Well, I was just saying, it was always interesting, wasn't it? Because when these deadlines approach, so obviously we've got a 2025 deadline now for a lot of things. You know, as these deadlines approach, people start jumping on the courses. As you well know, back in 2008, we were all gearing ourselves up, ready for. Well, we were being told, weren't we? I think, what was it, 37 pence a kilowatt hour? I think we were going to be paid for heat pumps. I think it was ground source, wasn't it? I think it was about the 37 pence mark. It was going to be very similar to solar PV. You would get that every kilowatt hour that you generated through using your heat pump. You would get that, or it would be deemed. And everyone was the courses were booked out. No one was teaching the right stuff, obviously, but all the courses, all the training was booked up solid. The ground source heat pump one that I went on at the time, we couldn't get on it. We were booked about 2 months ahead, I think it was. It was that, you know what I mean? And the thing is now we're struggling for engineers, big style. There's just not the engineers out there. But now they've tightened up the course material and everything else, where back then it didn't matter, but now it matters. And it's kind of having, I think, sort of the polar opposite effect. It's putting more people off going for heat pumps than it is encouraging them.
Well, it's evolving, isn't it? Yeah, it's evolving. I can understand that. People who are used to just, like, say, putting a white box on a wall and then, you could do 2 of them a day, couldn't you? You know, heat pump takes a lot longer, and it's an
with
education.
due care and attention. Yeah.
Well, it tends to be just straight swaps, but I understand. I'm a big advocate of training. I understand it's time. People coming off the tools and having to spend, you know, taking, you know, the losing work, but it needs to be done right. You know, and part of my role is to sort of, you know, lobby government to support training and support the right training. And I think, you know, for the first time in a long time, it is starting to be done the right way. But again, just designing a course, you know, going back the days of the 𝗵𝗲𝗁𝗁 courses. Plus, there were good courses, to be fair, at the time, but I did feel a bit of a fraud myself, because I think I left the college about 2011. When did the RHI start? About 2013? Right?
Yeah, about 13.
Yeah, 14. So people all geared up for this course, and then when they came out, and I don't think you really had to have a qualification to fit a heat pump on MCS at the time, and that's obviously evolved over time. So I put loads of people through courses, but the college made a lot of money, mind. So they were happy.
So just still on the training subject, then you guys obviously you trained as gas engineers, and then you've gone over to heat pump MCS stuff. What's the sort of, you're talking about getting nerdy and it being more complicated, and that seems to be, because there's a few comments on the chat about it, seems to be the conception, the I don't know, misconception, preconception, whatever it is, that it is more complicated. But you know, what do they have to do in order to make that switch? What's that sort of process look like?
I personally would say we don't need more heat pump courses. We need more design low temperature courses, because that can be for a boiler and potentially an oil if it's done right. And there are now certain oil systems that can run at certain low temperatures. But if you get the low temperature bit out of the way, the gas boiler on the end of it, or the heat pump on the end of it, is going to run at its most efficient. Yeah. End of. Yeah. That, you know, it's basically the same course, but you could fit whatever engine on the end of it you like. It's not complicated. It's basics. And as I said, you could heat pump itself. The heat pump technology itself is very simple. It's actually really simple. But what you bolt it onto is where the complications are. So if what you're bolting onto hasn't been designed for low temp, that's when it goes wrong, and that's when heat pumps get a bad name. The problem with gas boilers is, or a good thing, depending on your view, is they can sustain being connected to a bad system. They can cope with that. But a heat pump is
the difference between a good gas boiler system and a bad gas boiler system is what, 15% efficiency?
Yeah.
And a good heat pump install and a bad heat pump install is 200% efficiency, and that's like twice as much a year to run. Yeah, that's massive. And I think everybody instinctively knows, if you stand in front of your fridge, or you leave your fridge door open, or you open and close your fridge, everybody instinctively knows the fridge is going to suffer. We are heating our house with a fridge and a flow machine, not a blast furnace, and it's completely different methods to heat the house. And I think that's the key thing for people to understand. It's a different beast.
Richard knows this, because we done it on a podcast many years ago now, and I done a rough calculation. You know, there's 26 million gas boilers in the UK. If 15 million of them were fitted with weather compensation devices, you could potentially save enough gas to heat another 4 million homes. And that's
don't doubt that. Yeah.
That's geeky. That is being geeky, but it's crunching the numbers. And you know, you could be, and I think I could even worked out how much gas the network would save, and their earnings and everything else. And obviously they would get a drop in earnings because you're not burning so much gas. And unfortunately, the cynic in me feels that the gas industry want you to buy more gas, and the gas boilers industry want you to buy more boilers.
Yeah, I mean, if you look at the Salford test we just done on the gas boilers, which the Nesta have published, right? So I was involved in that. It's So if we go from just the energy savings alone, it would just prove that the amount of wastage there is. So where you were saying that weather compensation point, that if we weather compensated all the boilers out there just as a start without heat pumps or whatever, the amount of gas saving would be massive. So going from 80 to 50 was a 23% gas saving. That's what it was. Yeah. Obviously, that's one scenario, but that shows the amount of energy that we can save. So, you know, what Si said was so right. If you get a heat pump wrong, and you know what I mean, the difference could be between, like you said, 200 and 300% efficient, or maybe 400% efficient, depending on what it is, you know, and that's a massive difference. And, you know, that's how heat pumps get a bad name. I saw in the chat, someone said, energy's energy. Well, that's right. But they wouldn't fit a heat pump in with a family that's got a timed scenario. So he said, however, working family who have their heating on for a few hours in the morning and a few hours in the evening be very disappointed by the running costs of a heat pump. And that they also shouldn't be fitted in a drafty property. So, I mean that's where I'm saying you don't open and close the door of your fridge. You know, it's the same thing. It's a different beast. It's a completely different method to heating your house. You can set it back. You can turn it down. You can do all the things you can with a boiler, but you don't turn it on and off like you do with a boiler.
And so, I mean, Simon knows you and I, Simon, we fitted heat pumps in stone cottages, farmhouses, chateaus in the south of France. I got asked to do a chalet, a chalet in Switzerland that was regularly got minus 15 in the winter, and it was 10,000 feet up. If they're designed right, they work. And it is literally a low, slow burning technology. And what you're doing is you're building the heat into the fabric. And fabric is key as well in the ingredients. If your fabric is good, it retains the heat you're putting into it. And with a gas boiler, what we tend to do is we put all the flames on, and the actual property, or some of the older stock houses in the UK, do not retain that heat. So at the same time, you then need a bigger flame to keep you comfortable. So if we insulate properties properly, you need less energy to keep them heated. And it's simple. It's simple, man.
Interesting little point on that, Ken, right? I don't know whether you're going to like this or not, right? But we did the tests at Salford were done on a SAP profile, so 2 timings per day with a gas boiler. Okay, so not a heat pump, gas boiler. we did a 70. No, what did we do? We did a 50-degree flow temperature test, but with a 17-degree setback during the time periods. Yeah. And it used as much energy as if the boiler had been running during those 2 on-off periods at 70 degrees. So it actually cancelled out any of the savings during those 2 SAP periods. So just, you know, it was quite interesting because there's a lack of research around that, isn't there? Because everyone out there sort of says, well, you know, obviously if you do time it between periods, then, you know, that's actually leaving it on all the time will use more energy, might increase comfort levels, but will use more energy. And I always think of heat pumps, you know, is that a limitation of, you know, of the technology out there at the moment? You know, will heat pumps evolve? You know what I mean? Because I'm always looking, you know, as like Rhiannon as a scientist and me as an engineer, I always think, well, you know, heat pumps have always got that scope to evolve. Do you know what I mean? That I don't always think. I think what we've got right now, you know, if as long as you give it enough flow and you keep it running and you keep it as a background heat and you know what I mean. So it's always on, a bit like a fridge technology. But I always think, you know, are we there with it yet? Or you know what I mean? Are we there with the technology yet? Or has it got scope to go more? Or I don't know.
That's what I find. That's what's exciting, isn't it? That's exactly it. That's
the challenge. Yeah.
I mean, what's going to happen next? I love it.
Richard, I think that's a really good point. And if we took Simon, if we took looking at heat pumps a few years ago, you know, they weren't talking about getting up to 70. You needed additional you know, electric elements to get to 70 degrees. Yeah. Now we do have heat pumps that can get to 70 degrees just on refrigerant process. We you could now potentially put them in the same box as your 2 hours a day, 3 hours in the evening, 2 hours in the morning, 3 hours in the evening, because you are achieving that sort of temperature. And I think the thinking of we run it long, slow and low is because heat pumps back then were capping out at 50, 55 degrees on the refrigeration, and they were working their nuts off at trying to achieve those temperatures. So their COPs and SCOPs were really poor. So and so you've got this steep angle of you're heating a house at 70 degrees. Of course, it's going to heat that house whatever house it is, it's going to heat that house a lot quicker than even if you run your gas boiler at 30 degrees, it's going to take a lot longer to heat that house. So I think with the advantage of the new technologies, and I know a lot of people talk about it now, we can swap our gas boiler out for a heat pump that can do 70 degrees. That's great. If you can prove and show me that's sufficient, and we're still getting good
that's exactly it. What nobody's talking about is the DT difference, and I think that's the key thing. What we need to do, Rich, is get to Salford with a couple of Aratherm.
We do, mate. We do. I've said this actually. What would actually be a really interesting test, because I know about efficiency, but there's efficiency and then there's kilowatt hour usage. Do you know what I mean? You could run a heat pump inefficiently and actually use less kilowatt hour usage for the same. You know what I mean? For the same amount.
We need to prove this. I mean,
that's what I mean, because there's a lack of.
My open loop no buffer systems, and I
can
very direct. They're very responsive.
Yeah.
As soon as you put a buffer in, you got to wait to get up to temperature and all the rest of it before you get any heat into the house. So I dearly love to be at Salford with various different.
It needs it. You know what? It needs it, because I mean we had exactly the same of this with flow temperatures, right? We looked out there and we tried to find the data around flow temperatures. There was nothing, right? There was absolutely no data out there. So Nesta invested in that to have those tests done. You know what I mean? To get that, but it'd be great to have that analysed properly in a controlled environment. Because. Ultimately, a lot of people saying, keep it low and flow, but what actual data is that based around, and what scenario is that put in? And the problem is, because obviously one piece of advice doesn't fit every installation.
No, it doesn't.
It's just like Salford Test House doesn't represent every single scenario out there. It can't. It's one scenario, but
that's it, Richard. That's why in some older properties we still have to back a few years ago. So you had a low temperature heat pump, but because it could only its efficiency dropped off the cliff when it went past 40, 45 degrees flow. You then to have bivalent systems and hybrid systems. But now we've got those heat pumps that can achieve 70 or 60, 70 and still get 2.5, 3 COP. We don't need the oil or the bivalent on the end of them, but the comfort and the quickness to that comfort level in that property is increased. It's a much steeper. I can get there a lot quicker now because I've got this new refrigerated heat pump, a new refrigeration gas. It's exciting. I think there will come a day where you could take the average 2-bed, 3-bed house, rip out the boiler that's most probably about 18 kilowatts, and you only need 5, and put a heat pump on it, and away you go. It'll be done.
I think it's a good point, saying I think one thing data is key, and I work for a consultancy, and we look at data and analyze data and produce reports. And not so much the level of detail that the project you've been involved with, Richard, with Nesta, but that's we've been reading that report and it's great. But there was a big scheme last year, and it's still ongoing now with the electrification of heat scheme, where there was 750 properties across the UK, fitted with heat pumps and monitored in various house types and archetypes. And I was involved with the 𝗺𝗻𝗁 scheme in the southeast. And to be fair, the 𝗵𝗲𝗁𝗁𝗁 came out and said every property is suitable for a heat pump. But I keep saying it, and I'm on a public platform now, begging 𝗵𝗲𝗁𝗁𝗁𝗁 release this data to us, please, so we can understand which properties, the nitty-gritty, because it was all part of, I was involved in the monitoring systems as well. And part of my job was looking at the monitoring systems. There was a certain sort of threshold that the monitoring had to hit. Why isn't it that threshold? Is there a problem with the system? And it was a really intuitive monitoring system, and you could pick up lots of issues. People leaving their Legionella cycle on every day. People saying the bill's £500 when actually the heat pump was only using £100. And long story short, we actually found out the customer had a car charger fitted at the same time, but didn't understand that car charging costs money. So monitoring, and I'm a big fan of monitoring, systems analysis, and even stuff as remote diagnostics, which is out there and available. A few manufacturers offer that as well. So, but data is key, and then we can prove we know the technology works if it's installed correctly, but data is then we can prove. But so I'm hoping if anyone from 𝗵𝗲𝗁 is watching this, please release that data.
That sort of data is what's going to quell all these questions that everyone's having about the different house types and what happens if they're a working family and they go out during the day and it's only on blah, 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 blah. So that sort of data is exactly what the industry needs.
It is, but also put into a format that people can,
understand.
People haven't got time. Well, I haven't got any brain power left at the end of the day, so it needs to be put across in a way, little snippets, little things, maybe a podcast, maybe something that's just more accessible as well.
I think you just want to need to know what's my house type, and it's very simple. We've got like a really good team. I actually sit in the analysis team, which is great because I struggle with spreadsheets, and the guys are great who I work with, and we look, and it is keeping things simple, and that's what it is. It's saying you've got this house type. If you run X amount of heating X amount of times a year, this is the expected savings. And I know 𝗵𝗲𝗁 are doing a lot of funded projects at the moment, and they really want to give customers, a really good view of running costs and install costs. But they're trying to use technology. So I think you might have seen, I think Eon were promoting where somebody walks around with something on their head and surveys the house as they walk around. Have you come across that? Great to see how good that is. Fine, brilliant. Does a lot of heat, takes a lot of data. But yourself, is Mrs. Smith got a grand piano in the corner and you've got to pull the floorboards up I'll fit this radiator. But again, I'm a big fan of moving technology forward. But again, this data is key, and once we got it would sort of quell all the naysayers very quickly. If you can say 3-bedroom semi-detached house in the northeast of England, champion for a heat pump. There you go.
And getting that message out to the consumers and also to the installers so that they can tell their customers about it. And that's like, it's a two-pronged attack, isn't it? It's kind of like getting the installers that information, but also whose responsibility is it to educate the consumer in the UK? That's the big question here. All of us.
All of us, yeah. I think all of us have got a responsibility. Yeah, whoever you are in the industry, Energy Saving Trust, National Energy Action, or a Great Fuel Poverty charity, government, us as in the industry, the clients who we work for, everyone's got a duty, but it's got to be the right message, and it's got to be, correct and accurate, and it's valid. That's the key thing.
Absolutely, Graeme. We're finding that the public are really knowing a lot more about these technologies now.
Yeah.
And even going to the extent of I've got this gas boiler, can you make my gas boiler run more efficiently? And obviously there's been plenty of campaigns on social media about turning your gas boiler down, which is great. But people do know, and I think Simon Richard might back us up on this one. A lot of people that already come to us for a heat pump have done tons of research, absolutely tons of research already. They know how it works, and in some respects, I've seen situations where some clients know more than their installer.
Absolutely. I always ask, what research have you done? Because it gives you that platform as well to, where you have to start. But it's one of my first questions, and people being interested in the industry and actually paying attention is, it's a product of the energy crisis and everything that's happened in climate change and all those things. But the interest that's there now is only going to project, it's only going to be good.
It's only going to grow. It's going to continue to grow.
I was going to say, I love the data geeks. Damon Blakemore's got one at the moment, isn't he, on Twitter? And
I met one today, Rich. You would not believe this loft I went into today. He had a Worcester. He sent me an email. It was a lead. I kind of poo-pooed a few things in his lead. He sent me one back. It then sent me 4 emails with drawings and schematics, and I was like, "Shit! Is this what this guy wants, or is this what this guy's got?" Got Evo Home on a Worcester RI, multi-zone, blah blah blah. Anyway, took me into his loft. Oh my god! It was a painted grey floor. He had white ply walls. He had big halogen lights in there. It was beautiful. Worcester RI on an Evo Home. I opened the flap of the Worcester. It was on 80 degree. It was on max. But this guy was a proper. He was like, I got sensors here, and I've never seen a loft like it. I congratulate him on the neatest, smartest loft ever. I've never seen anything like it. And he was just he's gonna home assistant it. He's gonna flow meter it. He's gonna be that customer that we will all learn from. Actually, I can't repipe his house. He's had a 𝗵𝗲𝗀𝗹𝗃 heat loss done, 7 kilowatt house. I thought it's a 10 kilowatt house, but he's had a 𝗵𝗲𝗀𝗃 done. It's a 7 kilowatt house. I'll stick a 7 kilowatt heat pump in it, and it will be sweet as a nut. It will be lovely. I change the radiators to lower temperature. That'll be it. That's all I need to do. It's going to be a really easy switch.
Yeah, it's nice when it's like that, because there's and this is what installers need to appreciate, that there are people out there, like we've all said, that literally they know exactly what they want. They just want that right installer to fit it for them, and and they're willing to take a risk as well. A lot of these guys, they will take a risk on it, and they will put all the people to one side who poo-poo it and naysay it and go, oh no, you don't want that. You got a house it won't work with, high air change rate in the house or whatever, but ultimately there's always a strategy that can be implemented. I mean, like someone said about a bathroom extractor once. Oh, we got a really high extract rate, but you can buy bathroom extractors that recover the energy as well. So there's always solutions, isn't there, to heat pumps? And I don't think there is. We've worked in quite a few. We've seen a lot of bad heat pump installs especially around the 2010 mark. I mean, the worst one we ever went to was someone who put a ground source heat pump in and built up ground, and the ground was only about 0.5 meter thick. And of course, it was frozen. When I got there, it was frozen. You'd never seen anything like it. It was frozen. I think September I went there, and the ground was frozen solid, and ended up putting an air source in there. But everything else in that property was right. They had underfloor heating, they had solar PV, and the PV was brand new at that point. And it's just such a shame, because, like I said, if you join all the dots up, especially with PV, if the energy's free or very, very cheap, who cares if you're not achieving SCOPs of 4? Because it's not necessary. If you've got all the energy there, why, if you achieve the SCOP of 2, then that's very hard to do these days with some of these heat pumps. But if you achieve that using PV, you're still better than any gas boiler will ever be out there. Do you know what I mean? As far as carbon savings and everything else go, isn't it? So
these cold weekends we've been having recently, but sunny ones, my heating has actually come on, but the sun's been producing PV, so the heat pump's been running for free.
Yeah. But I'm finding people are wanting that a lot more. People are connecting the dots, like you say. They're interested. They want the full system. They want the PV to help offset the heat pump.
Yeah.
Loads more of those inquiries.
Can't do that with a gas boiler, can you?
No, you can't.
I tried to harness my gas, Rich, but it doesn't end well.
Show me your bucket. Recycled gas, Simon. I want your bucket of recycled gas, please.
I thought it's like. What do they used to call them? Gasometers. I imagine it's like his own, like Si's got his own gasometer in his garden. Do you know what I mean?
They're just
it's under my duvet. It's under my duvet, mate.
I don't know about that one. Good. That was that carry last night. Okay.
On that note, guys, I think it's been a massively useful session. We've had loads of comments. Richard, you've picked up on quite a few of them, but if there's anyone in the chat that we haven't answered, then I'm going to have a look at them, and we will come back to you on any questions that are put out there. We can share some links for low system temperature courses, can we?
Yep.
Yeah, we can share some of those later. And just want to say thanks to you all for your time on the Here tonight. It's been really, really informative. I hope everybody who's watched has found it really useful. And there's so many opportunities out there for meeting these targets and getting this training done and what the future holds. So hopefully it's changed some minds out there with our viewers. But thank you all very much. I'm going to end the broadcast now, and we'll see you again.
Thanks, Claire. Thanks,
guys.
Thank you all.
Bye.
Thank you.
Cheers, guys.
Bye.